Hello, today we're going to just do a brief overview of how to do calculations for reactions that are in solution. So at this point we now have three different ways to, or sort of three different media to look at when we're doing a reaction. We could have solids, which is where we started, where we go from grams to moles to grams, right? We could use the ideal gas law to get from the amount of gas to the moles. Or now we know that we can use the concentration of a solution to get from the volume of the solution to the number of moles using the molarity. So we're going to combine the three of these, right? And you don't always have to go from here to here, or here to here, or here to here. You could go from grams of one thing to liters of another, or amount of a gas to grams of a solid. All of those are options, and you now have all of the skills to do them. We're just going to add in the solutions today. All right, so these steps are going to look just like they have for the other stoichiometry problems that we've done. So first, figure out what you were given and what you're trying to find. Make a plan, all right? Figure out what conversion factors or equalities you're going to need in order to get from one thing to another. And this will always include a mole-to-mole ratio, which is from the coefficients from your balanced equation. And then you'll set up the problem and calculate what you're looking for. All right, so the first example I have is zinc reacts with HCl to produce hydrogen gas and zinc chloride. So this is the balanced equation for that reaction. How many liters of a 1.5 molar HCl solution completely react with 5.32 grams of zinc? So here we're only concerned about the two reactants. Right, what we know is how much zinc we have, all right? One thing that sometimes confuses students is if there's a molarity in your problem, that is a conversion factor. That is not where you're going to start your problem, okay? So the other number we have is 5.32 grams, all right? And what we're trying to find is how many liters of our HCl solution. Okay, so we'll use the molarity to get there. That will be one of our conversion factors. So first we have to get from grams of zinc to moles of zinc, and we'll use the molar mass to do that. Then we'll get from moles of zinc to moles of HCl, and we'll use our balanced equation. And then the last step, which is a little bit new, is getting from moles of HCl to liters of HCl, and we'll use our molarity for that. Right, so what this is going to look like when we set it up, the 5.32 grams will go in the front. All right, this is our molar mass of zinc. That's one conversion factor. 1 mole of zinc is 65.38 grams. Then we have our mole-mole ratio, which we got from our balanced equation. So 1 mole of zinc reacts with 2 moles of HCl. So that's where those came from. All right, and then the last step is to go from moles to liters of solution, and we're going to use our molarity. So remember that 1.5 molar means 1.5 moles in 1 liter. All right, so then I just do my math. Multiply everything on the top, divided by everything on the bottom, and you get 0.108 liters of HCl solution. All right, our next example is acid rain results from the reaction of nitrogen dioxide with water in the air. So we have 3NO2 plus an H2O will give us 2 HNO3s or nitric acids plus an NO. All right, so if we have 7.8 grams of NO2, and we bubble that into 2 liters of water, what will be our concentration? So this one looks a little bit different than the one that we just did. So again, our starting amount is our grams, all right? And then in this case, what we're trying to find is the molarity. So I'll do this one as an example so we can see how that works. So our plan is going to be to go from grams to moles, and then from moles to moles using our balanced equation. And then the last step won't be a conversion, but we'll use the liters given in our problem to find molarity, since we know both moles and liters. All right, so what we're going to do is go from 7.8 grams of NO2 to moles using our molar mass from the periodic table, and then we'll do the mole-mole ratio from our balanced equation. So 3 moles of NO2 will make 2 moles of HNO3, so that's where the 3 and the 2 come from. So in this reaction, we'll make 0.113 moles of HNO3, right? So if that is, if we take that number of moles and we dissolve it in 2 liters of water, all right, then what we're going to end up with is that number of moles per 2 liters gives us a molarity of 0.057 molar. All right, and then our final example here, we're using the same balanced equation. This one, we're going to use a gas, all right? So if we are at 1 atmosphere and 298 Kelvin, you know that if you're given temperature and pressure, that probably you're going to need to use the ideal gas law. How many liters of NO2 are required to produce 0.275 liters of a 0.40 molar HNO3 solution? So there's a lot of numbers here. These two numbers are going to go into the ideal gas law. All right, we're given a certain number of liters of a solution, and we're trying to find liters of a gas, right? So this one is probably the most complicated in terms of figuring out what you're doing. So the 0.275 liters will be our starting amount. That's how much HNO3 we are going to make, all right? And we want to know how much NO2 we started with, or we would need to start with. Okay, so our plan is going to be to go from liters of HNO3 to moles, right? That HNO3 is a solution, so we'll use the molarity to do that conversion. Then we'll go from moles to moles using our balanced equation. And then the last thing we'll do is go from moles to liters, and this is liters of a gas. So for that step, we'll need to use the ideal gas law. Okay, so for the first two steps, we'll have two conversion factors. First uses the molarity, 0.4 moles per liter. That's where this 0.4 molar will come in, all right? Our mole-mole ratio, 2 moles of HNO3, is formed by reacting 3 moles of NO2. So that means that we needed 0.165 moles of NO2, right? If that is at 1 atmosphere and 298 Kelvin, we can use our ideal gas law, all right, and plug in those numbers. So we have our pressure is 1 atmosphere, our moles is 0.165. This is our gas constant, R. All right, and then our temperature is 298 Kelvin. So if we solve for V, we get 4.04 liters of NO2.